the types notebook. And so the last type that I want to introduce at this point in time is something called a struct or a structure in C. So in Java, the mechanism to create a new type is to either create a class or an enumeration or a interface. In C, your mechanism for creating a new type or a user-defined type is the structure or struct. So a struct is a composite data type, so that means it's made up of one or more variables, which are called members of the structure. And you group the variables under a single name in a block of memory. So the way it works in C is that that's an example of a structure there. So you group your variables into a single thing called a struct. Right? In memory, the members of the structure are laid out one beside each other. There could be some padding in between individual members, but all of the members are grouped together in one place. So an example of a structure, similar to the one we looked at in 124, is a structure for two-dimensional points. So here is a structure that consists of two double members, right? So x and y. So these are the x and y coordinates of your point. Structures in C, there is no constructors, and there are no methods that belong to the structure. So if you want operations on the structure, what you do is you write functions that take your structures as inputs and possibly return them as outputs. Right? So no constructors, no methods. Because there's no constructor, you have to initialize structures. The programmer has to initialize the members of the structure themselves. So one way you can do that is you can use the brace notation, right? Just like you can initialize the elements of an array. And so here, struct point2p equals brace point1, point2 sets the x member to point1, and it sets the y member to point2. When you make the structure, the struct word is part of the type name. So this structure up here, struct point2, its full type name is struct point2, right? So the struct becomes part of the type name. Now, fortunately for you guys, because you took 124 and you know Java, using a structure is just like using a reference to an object in Java. To access the members, you just use the dot notation. Right? So it's pretty easy to use. So here's my structure defined. Right? So somewhere somewhere in this compilation unit, we've got our definition of a structure. Then we have our main function. Right? Inside the main function, we make a variable p, whose type is struct point2, and we set its the coordinates of the point to point1 and point2. Right? To access the x and y coordinates, you can just write p.x and p.y. Right? So just like using an object in Java. If you want to change the the values of the members, well, it's the exact same thing, right? It's p.x equals something, p.y equals something. And so this makes a point, point1, point2, prints the point, then changes the coordinates of the point, prints the point again. And so when you run it, it's not surprising, right? You get the point1, point2, and then you get 100, 200 after you've changed the coordinates of the point. Right? Again, there's no methods that belong to a structure. So in Java, you would probably override toString to print out a point. Right? You can't do that in C. You have to do something to print out the coordinates of the point. So here I'm using printf. Right? You might provide a function that prints out a point if you wanted to format it in a different way. Right? But there's no standard function that you can call like you can in Java. Right? Java's got toString. There's no standard way of printing out a structure in C. Okay, there are some differences compared to Java, though. So it looks a lot like Java, but the way it actually behaves in memory is different. So in Java, you've got all classes are instances of are reference types, right? So your variables are actually storing references to stuff. Structures actually store the information. So if you make a structure, if you make a P here in this case, right? P actually stores the values 0.1 and 0.2, right? There's a structure, it's storing that structure there, right? So the values 0.1 and 0.2 are associated with P, which is different than Java, right? In Java, you've got a reference, so somewhere in memory, there is the object that corresponds to the reference, right? And it's there where the values are stored, right? So structures actually store the values of its members right here. And so that means assignment behaves differently with structures in C than assignment works with references in Java. Right? So when you make a new structure variable Q, there is a structure object somewhere in memory, right, associated with Q. It's uninitialized, so it's X and Y coordinates. You don't know what they are. When you write Q equals P, right, what that literally means is that copy the values of P, so copy its X and Y, into the X and Y belonging to Q. Right, so this is actually assignment here in C with a structure. Right, in Java, you'd have to call a copy constructor or some sort of method that can copy an object to actually copy the object. Right, here, you really do get a new copy of the structure. If you print out the coordinates of P and Q, not surprisingly, it's 0.1 and 0.2. Right, if you change the coordinates of P and you change the coordinates of Q, P and Q end up having different coordinates. Right, so if we run this, right, so P and Q, Q after I copy P, the coordinates are exactly the same. Right, after I change the coordinates of P and Q have different coordinates. Right, they're still different. They are different structure variables, and so they have their own X and Y members. Right, so assignment behaves a little bit different. Assignment behaves very differently compared to assignment of references in Java. And that's more. So the only thing I haven't told you about is what is a pointer, right? And once I tell you what a pointer is, that's basically all of the new stuff you need to know from Java. So the fact that there's still like 6.5 weeks of class might surprise you at this point, right? Because there really isn't a whole lot that's new compared to Java. But learning how to use these things called pointers and all these other facilities of C is what's going to take up the rest of our time. So that's the types notebook. Anybody have any questions about types? All right. So let's move on to the next notebook. So the next notebook is scope. And scope behaves more or less the same as it does in Java, but there are, again, some differences. So scope. All right, so in C, so to be clear, I guess I should review what scope and lifetime mean. So scope is where the part of your program where a name is usable, right? So names include function names, variable names, right? So the part of your program where a name is usable is the scope of that name, right? So C and Java share similarities in that blocks, so the braces, delimit scopes of, delimit different scopes. Right? There's also something called the lifetime of an object. So in Java and Python, you generally don't care about the lifetime of an object, right? The language takes care of, you can create an object, you can then use it, and then the language takes care of getting rid of the object for you. In C, that's not the case. So in C, you have to create an object, you can then use the object, but then you're also responsible for when it goes away. So the lifetime of an object in C is under the control of the programmer. And so it's important that you understand the different kinds of lifetime that an object can have in C. This sentence shouldn't be here. There is no linkage notebook. So you can just ignore that if you're reading the notebook. All right, so first we'll talk about scope. And so in C, for our purposes, there's 3 types of scope, and really there's only 2. The language actually has 4, but we don't care about the last one. So there's something called file scope, and there's something called block scope. The third one that you might encounter in this course is something called function prototype scope. The last one we don't care about because we don't talk about the feature of the language where it's relevant. So file scope and block scope, you're sort of familiar with these concepts already from your previous courses. Right. All right, so file scope. So any name that's not inside a pair of braces is said to be at file scope. Right? So if you have a variable that's not inside a block, it has file scope. all functions are at file scope in C. So where you can start to use a name or refer back to a name in C is after you've declared it. Right? So at the point of declaration and after in the file that you're in, you can then use that name, right? Which is different than in Java, right? So in Java, if you have a member of a class, right, a field of a class, you can use that field anywhere in the class. It doesn't matter where the field was declared, right? Most programmers put the fields at the top of the class, but you can put them anywhere you want to. And the compiler will figure out where the fields are in the class for you. It doesn't work that way in C, right? So you can start to use a name at the point where it's declared and onwards. All right, so remember, anything not inside a block, file scope. So we got a program here called scope.c. So there's our include statement, because I'm going to print stuff out. So there's a variable j, right? It's not inside of a block. Therefore, it has file scope. Right? You can start to use j immediately after this line. Right? So anywhere in the program, you can now start to use j. Sorry, back up a little bit. There's my function f. Right? F is not inside of a block. I don't believe it's allowed to be inside of a block either. And so f has file scope. Right? At this point of the program, so anywhere after this point in the program, you can now refer to the function f. Right? K, not inside a block, has file scope. Right? Is usable from this point onwards. Right? Notice that in the function f, there's a line here that's commented out. Right? It tries to use k, and we'll see in a minute that it doesn't work. And finally, here's our main function. Main's not inside of a block, so it's also at file scope. Right? All right, if we run the program, it's going to generate some output. The output it generates right now is not important. Right? So what is important, though, is that main can use j. Right? So it's accessing the variable j right there. It's accessing the variable j right there. Right? The variable that it's accessing is the j that is up here. Right? Oops, sorry. Okay, so main calls f. Right? F does some stuff. It's not important what it does. Right? Inside f, there's a line that tries to access k. So I'm going to uncomment the comment. Right? And if you try to run this, the compiler barfs. Right? It says error k is undeclared, first use in this function. Right? And that's because k was declared here, so it's usable at this point onwards. Right? It's not usable inside the function. Right? As far as the compiler is concerned, this function doesn't know what k is. Right? So that doesn't work. All right. So that's file scope. So pretty straightforward, right? Not in a block, file scope. Now, if you are inside of a block, or if you're part of the function parameter list, those variables are said to have block scope. Right? So block scope simply means the variable is usable anywhere inside of the block in which it was declared. You're allowed to nest blocks, and you know this from Java, right? You can have blocks within blocks within blocks. Right? Every time you have a block within a block, the inner block is allowed to redeclare variables from the outer block. Right? And so we say that the inner block variables hide the ones from the outer block. You should probably avoid doing this unless you know exactly what it is you're doing, because it can be confusing to read code that looks like this. All right, so to illustrate the point, here's our function f. It has a parameter called I. Right? And so in this case, I has block scope. It's usable anywhere inside of this block here. Right? It's usable inside the function f. Notice that f makes its own variable j. Right? And so that j has the same name as the file scope variable j. So inside the function, from this point onwards, this j refers to the local variable j and not the one at file scope. Right? So again, this can be confusing reading this kind of program. So j has the value 1. The outer j, its value doesn't change. Right? Whatever value it happens to have, it still has that value. That I changes that I. Right? This I and j refer to this I and this j. Right? And now, to make things even more confusing, we have a loop where we introduce a loop variable I. Right? So now, inside the block of the loop, whenever you use I, you're referring to the loop variable I, right? And not the parameter I. Right? So we say that this I hides the other variable I, which is the parameter. Right? Similarly, we introduce a new variable j. Right? Inside the loop, whenever you refer to j from this point onwards, right, it's this j that's being used. It's not the j defined. It's not the j that was declared by f, and it's not the j at file scope either. Right? So if you trace through this program, when you go into the loop, it's always going to print j as 2, right? Because it never changes the value of j. Inside the loop, it's going to print I is 0, then I is 1. Right? So if you run that little program there, right, there's your for loop. Right? First time through the loop, I is 0, j is 2. Second time through the loop, I is 1, j is 2. Right? Before the loop, when we print out the values of I and j, it's going to be 1 for j, and whatever I happens to be. So whatever value we passed in as the argument. Right? So apparently we passed in 101. Right? After the loop runs, notice that I and j are 101 and 1 still. Right? They're not 0 and 2. And also notice that the j at file scope, its value never changes. Right? We never touch it or assign to it except when we set it in main. Oh, no, we didn't set it in main. So its value never changes. Okay, so those are the two important scopes that we deal with in this course. The one other place that might catch you is this thing called function prototype scope. So in C, you can declare a function but not define it. And that's exactly what a header file does. Right? Header files typically say these functions exist, but there's no implementation for them. The implementation is somewhere else. And so the way that you declare that a function exists is exactly the way that you declare a method exists inside of an interface in Java. Right? You just write down the first line of the method, or the function in this case, and put a semicolon after it. Right? So there's a function prototype of a function called SumFunction. Right? Once you have the function prototype, you can actually call the function. Right? So inside my program, I can now write some function and pass in a value for a. Right? I can even compile that program into object code. I can't convert it into a runnable program, but I can compile it into object code. Right? If I want to turn it into a runnable program, I have to define some function somewhere else and link that function into the program. Right? But you can compile a translation unit only with the function prototypes. Right? You don't actually need the definitions. So there's my function prototype. That's not very interesting in this case. That variable a has function prototype scope. That's all it means. Right? You're declaring a function. Your parameters have function prototype scope. So when does this matter? So you have to remember how scope works in C. Right? A variable is usable after it's been declared. Right? So here's another function, prototype. Right? Here I've got two parameters. I've got two parameters. One is a int called n, and then after it is an array called a, and it looks like it's supposed to be an array A of n elements. That's what it looks like it's trying to say. That prototype is fine. Right? What you're not allowed to do is you can't reverse the order of the a and the n. Right? So if you write it in this order, you're saying there's an array called a of length n, and so now the compiler will complain. It'll say, I don't know what n is. Right? N doesn't come into scope until after a comes into scope, and so that's not allowed. Right? You need n as part of the declaration of a, so n has to be declared before a. Right? So this is correct. That is not. Right? And that's the only time that you'll run into a function prototype scoping issue. All right, so you now know about scope. It's pretty similar to the way it works in Java. You just have to remember that the main difference in C is that you can't use a name until you declare it. Right. Okay, so the next big difference between C and Java is the lifetime of an object. So the lifetime of an object, the language specification refers to its storage duration, right? And so that just means how long is the thing in memory for, right? That's what the word storage is for. Right. So in C, there's 4 kinds of storage duration. We don't care about the 4th one. We don't care about thread storage duration. That's an issue for your operating systems course, so SIS 324 if you take it. But the other 3 could come in, are important for us. Right. So there's automatic storage duration, there's static storage duration, and there's allocated storage duration. The allocated one is the one that's new for most of us here, for most of the students here. Right. So the allocated storage duration is the one that is significantly different compared to Java and Python. Okay, so automatic storage duration, most of you are familiar with this, whether you know it or not. Right. This is the storage duration that is the default storage duration for anything declared inside of a block or as a function parameter. Right. So the way this works is that, remember, storage duration is how long is the thing in memory for. So the memory for the thing is allocated when the block in which the object is declared in is entered, right? And it's deallocated when the block is exited by any means. Right. Okay, so J, not automatic storage duration, right? It's not inside of a block. I is a parameter, so it has automatic storage duration by default, unless you say otherwise. Right? The lifetime of I starts whenever you call the function f, right? So you enter the block, right? And it ends when you exit the function. So in this case, the lifetime of I is until the closing brace here. Right? Inside the function, there's j, right? It has automatic storage duration. It's inside of a block, right? Its lifetime starts where the cursor is there, right? Immediately after its lifetime technically starts when you enter the block. So it technically starts when you call the function f, right? And it's usable, it lives until you exit the block, until the last line of the function runs. Right? The same is true, this is different here. So here we have a loop variable I, right? Its storage duration starts when the loop runs the first time, right? So when you enter the block in which it's defined in. So it's going to be here, right? Its lifetime lasts as long as the loop is, until the loop runs its final iteration. Right? So this loop runs twice, so after the second iteration, I disappears. Right? And the same is true for J. Right? That J also disappears after the loop runs twice. All right. For some reason, this slide is duplicated, the cell is duplicated. I'm not sure why. Okay, so objects with automatic storage duration, they are not automatically initialized, right? So if you declare a variable and you don't initialize it, it can have any value, right? So if you declare a variable inside of a block, you don't give it an explicit initial value, right? Then the value is indeterminate, right? Could have any value. Again, one of the problems with C is that in small programs, when you test it, often it'll seem like a variable with automatic storage duration is initialized to 0. That's not true. Right? It can have any value. Right? And it's super problematic because you can write some test cases and every one of your test cases might pass. Right? So your code assumes it gets initialized to 0. Right? You test it over and over and over again, it seems to pass. Right? And it's not until someone runs a bigger version of your program at some point in time that they report an error. Right? And your function's using an uninitialized variable. So here, I'm using an unsigned long to accumulate a sum. Right? So I'm going to sum the value of the first n unsigned integers. Right? So 0 plus 1 plus 2 plus 3 up to n. To accumulate a sum, you want the sum to start out as 0. So here I've got my variable sum. I haven't initialized it to 0, so it could have any value. Right? There's my loop. Right? Runs n plus 1 times to sum 0 through n. Right? Each time through the loop, we just add I to the sum. Right? Okay, so here I'm going to try to compute the sum of the first 1 natural numbers, then the first 2, then the first 3, up to the first 10 natural numbers. 9 natural numbers. Right? Let's see what we get. We do not get the right answer at all. Right? So the sum of 0 plus 1 is apparently that number there, which is definitely not correct. Right? The sentence at the bottom is the most important part here. Right? So if you're unlucky and you run this, you might get the correct sum for some values of n, or even all of them. Right? Simply because by chance, wherever the variable sum was declared in memory, that memory happened to be 0. Right? In this case, obviously it's not. Right? The correct way to write the function is to make sure you initialize this to 0. Right? And now you get the correct result. Right? This always catches some students in their assignments. Right? They forget to initialize a variable. Their code is otherwise correct, and they end up getting the wrong answer when it gets tested. All right, so that's automatic storage duration. Right? So the language basically takes care of the lifetime of those objects for you. Static storage duration. So if you have something at file scope, it automatically has static storage duration. Right? You're also allowed to declare variables as being static in C. The static keyword in C is very different than the static keyword in Java. Okay? So they mean completely different things. So when you mark a variable as being static in C, you're saying it has static storage duration. Right? The lifetime of these objects is the lifetime of the entire program. Right? So the language guarantees that the objects get created when the program starts to run, and it guarantees the objects get destroyed when the program ends. It also guarantees that the objects, their values are initialized exactly once before your program actually starts to run. Right? So before the main method starts to run, anything with automatic storage duration gets initialized to some specific value. What values do they get initialized to? So if it's a number, it gets initialized to 0. Right? If it's a pointer, which we haven't talked about yet, it gets initialized to the value called null, right? Meaning it points at no object. And if it's a structure, then every member of the structure is initialized according to these two rules recursively. Right? So if your structure has a member that's an integer value, it gets set to 0. Right? And if your structure has a member that's a pointer, it gets set to null. Right? As long as it has static storage duration. Right? So J has static storage duration. Right? Its lifetime is the lifetime of the entire program. Right? Its value gets set to 0 before your program starts to run. Right? K is not here. K would also be 0. So when this program prints out J as 0, it's actually printing out the correct thing. Right? J is guaranteed to be 0 in this case. All right, so you can mark a variable as being static. Right? So anything marked as static has static storage duration. Right? Its lifetime is the lifetime of the program. Okay. So anything at file scope marked static, including functions, so you can mark a function as being static, has static storage duration and is visible only inside of the file that it's in. Well, strictly speaking, it's visible inside the translation unit. Right? So for our purposes, it's visible inside the file that it's in. Right? So that's very different than what static means in Java, right? So remember, static in Java means that the thing belongs to a class of some, right? In C, static means static storage duration, visible only inside of the translation unit it's declared in. So it's sort of similar to a private static field in Java, right? Sort of. So here's a program that uses a static variable at file scope. Right? And it's going to compute and print the sum of the first n natural numbers, just like before. Right? Okay, so here we have our sum of the first n natural numbers. Right? This prints the sum. Right? Notice that it prints the sum using the file scope variable sum, so it's going to print out that value there. Right? And then we have a little main function that calls sum of with the value 10. Right? So you run the program, and we get sum of 10 is 55, right? So the sum of the first 10 natural numbers is 55, which is correct. Right? So that example right there is an example of a program that works as long as you call sum of exactly once. Right? Because you call sum of exactly once, and you don't touch the variable sum otherwise, right? This will be correct. So the first time you call sum of, sum starts at 0. Right? And then we accumulate the sum into that variable there. As soon as you call sum of a second time, right, sum's no longer 0. So you're going to accumulate the sum into a variable whose starting value is not 0. Right? So here, I'm going to call sum of 10 a second time. Otherwise, it's the exact same program. So the first time, you get the correct sum. And then the second time, you get 110, which is not the correct sum, right? It's 55 plus 55, because the second sum was accumulated into the file scope variable sum, right? So the error here is that sum of is not setting sum to 0 before it accumulates the sum, right? So you could easily fix this, right? So right there, sum equals 0. Now when you run the program, you'll get the correct result, right? You still shouldn't do it this way, right? The real error here is the fact that you're using a file scope variable when all that you really require is a block scope variable, right? There's no reason to be using a file scope variable here to record the sum, right? Just make a little local variable here and accumulate the sum into the local variable, right? That variable disappears when the function goes away. Right? And it always gets initialized to 0 as long as you remember to set it to 0. Right? So that's the way that static variables work. You can also declare a function as being static, although we will never do so. Right? So functions that are static are visible only inside of the translation unit that they're defined in. Now, what that should tell you is that if you don't mark a function as being static, that function is visible outside the translation unit. Right? So, for example, here this print sum method, function. Right? If I had another C file, right, you could actually call print sum. Right? And so you can the other translation unit can see this function print sum. Right? When you link the two together, right, it will link to this function here. If you mark this function as being static, that's no longer the case, right? Other translation units can't see the function anymore. Okay, if a variable at block scope is marked as being static, that's very unusual. So there is no, is that true? There's no analog, at least in the Java that you learned in 124. So if you make a block scope variable static, it has the same meaning as a static variable in general, right? Its lifetime is the lifetime of the program. It gets initialized before the program starts to run. However, it also maintains its value between calls to the function, right? So what the heck does that mean? So here is our static variable called value, and it gets set to 0, right? Our function here is count, right? So it's basically going to add increment to the current count, right, where the current count is stored in value. Right? So that variable value gets initialized only once. It's very deceiving. Right? This looks like it gets initialized every time you call the function. It's not true. Right? You marked it as being static, so it only gets initialized once. Right? Every other time you call the function, value maintains its value. Right? And so this basically behaves like a counter. Right? So here, we're going to pass in 0, right? Passing in 0 means add 0 to the count, and it returns the current count, right? So that should print 0 the first time. Right? Count 1 means add 1 to the current count and return the count, right? So we should get 1, right? Add 1 more, add 0 to get a count of 3. So notice that this thing goes up in increments. So because we're calling it with count 1 every time, the counter is going up in increments of 1. right? And so there's an example of a static variable inside of a function, right? The purpose of such a variable is to remember the value of something between calls to a function. It's a bit unusual, well, it's quite unusual actually, to need a variable that does this. Right? There's only one function that I know of in the standard library that makes use of this feature, right? And it's inside of a function that's quite unusual to use. And so we'll see that function much later in the course. So functions that retain information between calls are very uncommon. They're also not super useful. Well, that's not true. When you learn about threading, you'll realize that, so probably in your operating systems course, you'll realize that these things don't work the way you want them to. In a multi-threaded program, they're more or less useless. They're only useful in single-threaded programs, unless you do something to deal with the issue. All right, so the next storage duration, do we do it here? This introduces the next type of storage duration, but we're not going to use this for a while. So allocated storage duration is the storage duration that you use when you want to control how long an object lives in your program. Right? So C lets the programmer take full control of the lifetime of an object. Right? So they can control, C lets you control when the object, when memory for the object gets allocated, and when memory for the object goes away. Similarly, if there's any other resources that your object has a hold of, it lets you control when those resources are released, right? Allocated and released. The problem is that the programmer has to remember to release the resources, right? They have to remember to return the memory or whatever resources the object is holding onto. If the programmer forgets to do this, then the memory associated with the object never gets returned back to the program. So if you repeatedly forget to do this, your program eventually runs out of memory. Right? That's actually one of the main reasons why the creators of the Java language created the language in the first place. It was to deal with the fact that C requires you to manually allocate and deallocate memory. So remember, in Java, you don't care about the deallocation of an object, right? So when you're done with the object, you don't do anything special, right? Eventually, it goes away, right? And that's because the language takes care of cleaning up after you. All right. So if you're writing a program and the object that you're using needs to persist across multiple function calls, right? Perhaps to different functions, right? Then you probably cannot use automatic storage duration. Right? You can use static storage duration, but that means you only have one of that thing, right? Which is not very useful in most cases, right? So I can have, say, a static list, so a list at file scope, but that means I only have one list, right? If I want more than one list, somehow you need some mechanism that lets the objects persist until I no longer need them. Right? So that's allocated storage duration. And so the easiest or the simplest example of this is when you have a function that must create and return an array. Right? So in C, you can't actually return an array. The language doesn't let you. So the best that you can do is you can return what's called a pointer to the first element of the array. Right? And so a pointer is just the memory address of an object. So a pointer to the first element of an array is simply the memory address of the first element of the array. So here's an example of a function called intArray. Right? And so the idea here is that you want to make an array of that length. Right? This function doesn't initialize the array, so you get back whatever you get back an uninitialized array, right? And then it returns the array. Right? So in C, there are no zero length arrays. So if the length is 0, we're going to set the length to 1. We're going to make a little local array. So we're going to make an array the way I showed you. Right? So this thing here has allocated storage duration. Sorry, it has automatic storage duration. right? Its lifetime starts here. It ends when the block in which it's defined in goes away. So the lifetime of ARR ends there, which is not very useful, right? If ARR goes away, and this thing says it's returning an array, there's now this question of exactly what the heck did it return, right? So when you run this program, it asks for an array of length 10, and then it tries to access the first element of the array. And this one barfs. Oh, first we get a warning. Executable. Oh yes, first we get a warning. So the compiler tries to warn you, hey, something funny's happening here, right? The program did run. So we got this executable exited with the code -11, which says that the program crashed. Right? If you did this from the command line, you would get a different message. But Jupyter is trying to tell you the program didn't run successfully. Right? So the warning that the compiler issues is function returns the address of a local variable, which is exactly what's happening. Right? ARR has automatic storage duration. Right? It goes away when you, as soon as this return statement finishes running. Right? So ARR is an array, so it's just a chunk of memory. Right? The pointer that we return is the pointer or the address of the first element of the array. Right? If the array no longer exists, what that means is that that memory address is no longer valid. Right? And so when you try to access that memory there, if you're unlucky, it works, and you get back the first element of the array. Right? And that can happen. Right? In this case, we were lucky, and the program actually crashed, which indicated something went wrong. So we know there's a problem. So if you try to access a member, if you try to access an element of an array that no longer exists, that is undefined behavior in the language. Right. All right, so how do you fix this problem? So how do you write a function that returns an array? Because it sounds like that's something you're going to want to do, right? There's lots of problems that you'd want to solve where you want to return a new array of stuff. So there has to be a way to do it. And so the mechanism to do it is to use allocated storage duration. And so that's one of the major topics in this course, is how do you allocate, use, manage, and then return back memory that you've allocated for some purpose. All right. So that finishes that notebook there. And so allocated storage duration gets its own notebook when we talk about arrays in general. All right, any questions about the contents of that notebook? All right. I guess we have some time, so I just want to look ahead to see what the next notebook is to see if it's worth starting. So the next one is declarations. What's here? Okay, so there's nothing super new here. So I guess we'll, why don't we do this after reading week? So I guess we'll stop there for today and pick this up after reading week. Your assignment is out. It's been out since the beginning of the week, I think. So you should be working on assignment 3. And then after reading week, there is a test, right? So I think it's the Thursday after reading week. The test covers everything from the bash part of the course, right? So everything from running a little bash program all the way to writing a bash function, right? It's only 50 minutes long, so there's not that much I can ask you, right? So there's going to be small questions related to, there's going to be a bunch of small questions related to bash programming. There are a bunch of old tests already on OnQ that you can look at. Right? And so the tests you'll see are relatively consistent. And so you should expect something like one of the tests that are on OnQ already. Right? Any questions? Okay, have a good reading week, everybody.